In Chapter 10, we use the periodic table to help us solve conversion factors. So we're going to be solving this one right here. So the first step is to write what's given. And we know we're going to have to find the molar mass of H2SO4 because we see grams. So to find the molar mass, we have to take the individual masses of all these elements and multiply it by the subscripts. So you see I'm doing it here. Next, we're going to add all those numbers up to get 98.08. So that number is our molar mass. Now if we plug that back into our equation, we know it goes on the bottom because we need grams to cross out. Now we multiply everything across the top and bottom to get our final answer, and we have to make sure this is rounded in proper significant figures. In Chapter 5, we use the periodic table to help us solve electron configurations. We can break the periodic table down into blocks, and we could use this chart to help us. So we're going to be using an aluminum as an example. So aluminum's atomic number is 13. That means it has 13 electrons.
So we know that the S block can hold 2 electrons max, and we know the P block can hold 6 electrons max. Now that doesn't mean you need to fill it, but it's just the max, and that's all we need to know for this problem.
So now we're going to be filling in these boxes with the arrows until we get to 13 total.
In Chapter 8, we use the periodic table to help us solve bond problems.
A bond that is greater than 1.7 is mostly ionic. A bond that is between 0.4 and 1.7 is mostly polar covalent. A bond less than 0.4 is non-polar covalent.
Okay, let's look at some examples here. Take the bigger element and subtract it by the smaller element. And once we get that difference, it's going to tell you what type of bond it is.
N minus N is going to equal 0, so we know that's non-polar covalent. O minus Cl is going to equal 0.5, so we know that's polar covalent.